graphs of tan of x. So you might have noticed that I've mainly focused in other trig function lessons on graphs of sine and cos x, because in past exams they're generally the graphs you see the most. Sine and cosine graphs, and they want you to know them in a reasonable amount of detail. However, in CIE, GCSE, they do want you to have a basic knowledge of tangent graphs as well. So tangent graphs, as you can see, look completely different to sine and cosine graphs. Remember, sine and cosine graphs are like the wavy ones. Tan graphs are kind of going on like this. Completely different. So most past exam questions on trig functions have been based on graphs of sine and cosine. However, your course outline does mention that you need a basic knowledge of tangent graphs. These graphs look totally different to graphs of sine and cosine. Mark in any vertical asymptotes you see and describe any features you notice in the space below the graph. Do you see any asymptotes? Let's see if we can mark some in. Let's extend this a bit. Let's mark in any. There's more than one vertical asymptote. There's no horizontal ones, but there's a few vertical ones. So I'll just let you have a look and see if you can see them first. Let's make them nice and yellow. You might have noticed there's one here. There's also one here. There's also one here. And there's one back here too. So notice this graph's drawn for more than one cycle. So a full period would be here, and then back to here again, as in like it's repeated after it's done one full cycle. So remember, a full cycle is 360 degrees, 90, 180, 270, 360. So it's done a full cycle when it's kind of hit here. So see, once you hit, let's undo that. Once you've hit here, it's repeating again, because see, it starts, if we're considering this to be the start, is when it goes up like that. Here it kind of, there's a half a doovy-woovy, and then it kind of continues back up, and then it starts to do this doovy-woovy. Let's label in our thingamajiggies, I'm being very vague, our asymptotes. So our vertical asymptotes, asymptote, here's one at x equals 90. X equals 90. That's one asymptote. Notice the equations are kind of written here anyway, but let's just write them in yellow, just so we realize that they mark where the asymptotes are. 270, so I'm doing this on my laptop, so that's why the writing's a bit dodged. I'll fix that x up later. X equals 450. And this one here is at x equals negative 90. Groovy. What were you asking us to do? Mark in any vertical asymptotes and describe any features you notice in the space below the graph. So in terms of the domain and range, let's see. Let's go on a bit about that. So it's a bit smaller. I just want to be able to see it too. So we have a domain. The domain of, let me just say the domain is, okay, so domain is basically any ones that are not the asymptotes. So if it's not the asymptotes, if it's all real values except for the asymptotes, you can start to just say values that are not those values. What on earth am I going on about? I'll try to show you what I mean. So the domain is x is real numbers, basically, but not things like 90. X is not equal to 90. X cannot equal to 70. And so on, depending on what domain it's, like over what kind of area it's been supposedly like applying to. In this particular graph, we can say x, the domain of this particular graph, also not 450. So that means is not equal to 450. We also have the one back here for this particular graph. So depending on what graph you've been drawn, you'll have a slightly different domain, because maybe certain asymptotes wouldn't be included. Oh gosh. Oh gosh. Oh gosh, oh gosh, oh gosh. Okay. Let's do that. And so on, so I'll just put the word etc. instead. etc. Now in terms of the range. Range is a bit more straightforward, thank goodness. So range, looking at the graph, notice it goes infinitely upwards and then infinitely downwards as well. So we can just say YER, that's an easy one. A bit easier than writing the domain. So we can say Y is an element of all real numbers. Bit different to ones of sine and cosine. So sine and cosine graphs, remember it was XER, and Y values were between -1 and +1. So different domain and range to sine and cosine graphs. So yeah, in terms of the period, I was kind of like getting that wrong before. The period is just 180 degrees. So notice from here to here, sorry, I wasn't paying attention. So period, oops, from here, and then from here, it's repeated itself. So the period is from here to here. So that's the length of one period. So one period, because from here, as I said, goes upwards, and then from here, going infinitely downwards, then it goes up, and then at that point it repeats itself. So the period, in this case, is just 180 degrees, so it's a bit different to the sine and cosine graph. Period of 180 degrees, as opposed to sine x and cos x with periods of 360 degrees. That's if B is 1. So that's a different kind of thing, so I'll do that in a different colour. Anything else you might observe about these particular graphs? One thing that seems probably a bit obvious, but you might want to point out, generally it starts at 0, 0, similar to sine. So generally it starts at 0, 0, starts at the origin, which is coordinate 0, 0, similar to sine x. So in that sense it's similar to sine x. Anything else? One thing that you could point out, it does have rotational symmetry. So around this kind of point here, for example, if you rotated this thing, you would get 180 degrees, you would get the same shape again. So it does have rotational symmetry of order 2 around these particular points, because twice in 360 degrees, this little shape here will rotate 180 degrees and get the same shape, and 180 degrees again to get the same shape. Same thing at this point, there's rotational symmetry of order 2. At this point, there's rotational symmetry of order 2. So that kind of thing you could say. So if you want to add that in, you can. Is there anything else you might want to point out? Contains asymptotes, that's maybe something it's kind of like mentioned on the picture. Contains vertical asymptotes. So that's an interesting point. Can't really think of anything else. If you want to see what it looks like on a calculator, let's try drawing one of these babies. So we'll just do the basic graph of tan of x. So let's do tan. So go trig, tan of x. And, oh, crazy looking thing. What do I have my document settings on? Maybe I'm in radians. So you notice it's got this kind of going on. Settings, document settings. Oh, I'm in degrees. Okay. Anyway, whatevs. So it's just trying to make it so it is actually in degrees. Let's go menu, window zoom, window settings. -1, so let's see, -10, -2, I'll do roughly -2, up to 360 degrees, just to show you how it could be different. And so on. Let's do tan of x. Oh my. Okay, so if you're getting the same thing, I've just realized what's going on. It's because the graph settings. So remember, you can go to menu, and then in the graph settings, my general calculator settings are in degrees, but my graph settings are in radians. So see how I did that? Once I've drawn my weird graph, or once I'm in a graph, menu, settings. So I need to change my from radian to degrees.
Who are you talking to?
I'm making a video.
Oh.
And then I'll probably select make default. There you go. So now the graph looks a bit better. So now it's, and also like, maybe I'll kind of go up to, oh no, this one's 4 and -4. This one's -6 and 6. So see how they kind of look? They look pretty crazy. I'm just going to adjust my window settings. Window settings. So that I've got -20 up to 20. Okay. No, it's fine.
I'm gonna go eat my yogurt before I have to watch Jennifer.
Okay, yep.
See you, buddy.
See ya. So what we've got here is, oh sorry, I just need to fix this up. So we've got, that was right, and -20, sorry, this was meant to be 20. Didn't work properly. 20, there it is, okay, cool. So just showing you that it kind of looks the same kind of a thing as this. If you trace it, graph trace, you might sort of see that there are some, what they're called, asymptotes. So if you remember, if you scroll along at some point, see it becomes undefined. So see, once you hit the undefined, it shows you the asymptote, which is pretty cool. So I've got an asymptote at 270. There's another one over here. It's going to get there forever. Down here, it'll hopefully get to an asymptote one day. Oh, and there it is. Ta-da! Yeah, 90 and so on. Undefined, yep. So just showing you where we've got some groovy little asymptotes. Now we've got to do some stuff here. Okay, so use the graph of y equals tan x, the basic one, on your calculator and solve these equations for 0 to 600. So we need to do the graph of tan x, so let's pretend we haven't done it already. So y equals trig tan x, enter. Oh, got to adjust my menu. So we've kind of got to go from 0 to 600. Menu, window zoom. Go a bit less than 0 because otherwise you don't see the axis. So maybe -10 up to 600. What are these values equal to? 10, blah, blah. Let's maybe go to -20. Just so a bit more than 10. -20 up to 20. How's that look? Groovy. Again, if yours is looking a bit crazy, it's probably because of settings. Maybe you're not in degrees. So make sure you're in degrees. What we have to do is give your answers correct to the nearest degree. So what we're doing is we're graphing this, and we're graphing this. So graph. The graph of y equals 3, remember, is just a horizontal line. So we're going to graph that, and we're going to graph this one on the same set of axes, and we're going to find the intersection point. So just writing a little explanation of what we're doing just to start with. So we've got something to refer back to. Graph both functions on the same axes and find intersection points. That's how you would solve these ones, because they want us to do it on calculator. So here we go, groovy. So click a bit so we can put in the second one. Y equals 3 is the second one we're going to put in. See? So now what we've got to do is find all the intersection points. Give answers correct to the nearest degree, so the nearest whole number in that case. So I've got to go and do this now. Great. Okay, so menu, remember, analyze graph. Sometimes tracing gets you the intersection, not always though. Intersection, we've got one here. See? Get it? There's one. 71.6. We already know it's at 3 because that one's at y equals 3. 71.6 to the nearest degree, 72 degrees. Better start typing this in because I'll forget these. X equals 72. I'll put the degree sign in afterwards. Next one, x equals, put it again, menu, analyze graph, intersection, left then right, 252, again, and then there's another one, x equals, because when we're solving for x in this case. This, oh, yep, this last one here. This one here, I don't know if we don't quite see this one. It's beyond 600, so don't worry about it. So I'm just going to move that out of the way. Menu, analyze graph, intersection, there it is, 432 degrees. And as you can see, there's only 3. The other one here, it's beyond, it's out this way. You can always check, but turns out there's only 3 degrees answers. What I'll do is I'll take a little snip. Maybe you do a little sketch of your graph. I'm going to take a snip instead. So you do a sketch, I'll do a snip. I'll just plug it down here. Just so you're looking back on this, you've got something to refer to. Do a little sketch of your graph, like do the 3 little curvy worvies and do the line. So do, like, here's your axes from 0 to 600. I've gone negative 20 to 20. Go up to here. This one, remember, you've got your asymptote. You've got your asymptote at 90. Other asymptote at 270, I think, was it? The asymptote at 450. So you might want to draw in those asymptotes and your line y equals x. Y equals 3. So there you are, 3 answers. Don't forget to put your degree sign. And there they are. Next one, tan x equals negative 2. See, do I have to go again? Can I just delete this one? I think if I click on that, yeah, I can change it, can't I? Negative 2. See, I've changed it to negative 2. Bang, it's down there now suddenly. Can I get rid of them? Yeah, I can. Nice. Just get rid of them. Delete. That's just saying what the 2 equations were. Delete. And this one's at negative 2, so that's good. That's what we want to see. Tan x equals negative 2. Graph both of them. And then find their intersection. So let's see how many intersections we've got. We've got 1 here, 2, 3. I think the answer is saying there's 4. Let's have a little look. I'm stealing this from a book. No, there's only 3. There's only 3. Easy peasy. So 3, so we've got to find them all. Menu, analyze graph. intersection, here and here. And now let's do the other one, analyze graph, to save time, intersection, here and here. There's that one, menu, analyze graph, intersection, here and here. So I'm going to take a quick snip of that. There we go. It's going to make it just easy for me to write my answers. So we have three answers again. X equals 117 to the nearest degree. Then x equals 297 to the nearest degree. And then x equals 477 to the nearest degree. Now let's put in our degree signs. You probably did it as you went, I hope. Degrees, degrees, degrees. So that's all they're asking us. Solve, for us to solve, which means find x. Give your answer to the nearest degree, which is what we've done. Now I've got 10x equals 10. Same thing. Let's delete. Delete.
Hey you.
And delete. Okay, so there I've just paused and like gone ahead and done this one. So you can see I've snipped and pasted the answers there, and there's the answers there. Hopefully you did it yourself, but